Hello dear student of class 10th. It is our fourth part of first chapter physics. Okay. In the third part we have studied about moment, that means torque, and its formula. Okay. That formula was torque is equal to, means moment is equal to force into perpendicular distance. Force into perpendicular distance. Now, the topic is starting from factors affecting the moment. Means on what criteria, on what things basically the moment depends. Moment depends on two things as it is mentioned in the formula, that is force and perpendicular distance. Okay. So, factors affecting moment are magnitude of force, means how much the force is. Basically, if it is 5, if it will be 10, the moment will increase. Definitely, with the increase of magnitude of force, the moment will increase. Definitely, with the increase of perpendicular distance between the axis of rotation and the line of action of force will increase the moment. For example, I am explaining that with an example. If there is a rod which is hinged at A, which is hinged means pivot means fixed. Okay, and I am applying some force F1 here. Okay, then definitely it will rotate. The object will rotate in this direction. Okay, I am applying force in such a direction, that's why object will increase. If we increase the force, then the moment will increase, and if we increase the distance between the point of pivot and the line of action of force, also moment will increase. Okay, if I am applying force here, this will produce, that is F2, this will produce less moment rather than F1. If both of have same magnitude, then it will be lesser than F2 because its distance from the axis of pivot or axis of rotation is less. That is 2. I am saying that. Yeah, we may say that 2 or 1. In such a case, moment torque 1 will be F1 into D1. Torque 2 will be F2 into D2. In such a case, since D is greater than D1 is greater than D2, that's why torque 2 is less than torque 1. Okay? If I am not considering the force, if we consider the force, F1 and F2 is equal. Since F1 and F2 is equal, I am saying that. Okay, on two things moment will depend, that is magnitude of force and the perpendicular distance. Okay, moment is a vector quantity. Now next point is moment is a vector quantity. Since moment is a vector quantity, it has magnitude and direction. If we are going to calculate the moment of any object, definitely we have to tackle two things, that what will be its magnitude and where will be its direction. Okay, so for magnitude we will use this formula, force into perpendicular distance. Okay, for direction it will be tough way to find the direction. Okay, I am going to make it easy for you, so please focus on this point. For finding the direction, if there is a hinge, there is an axle hinged at point A, माना कि एक एक्सल है और ये A पे hinged किया हुआ है, then a force is applied. If we are applying force F on the another end where it is not fixed, the axle is not fixed, this rod is not fixed. This force have a line of action in this direction. In this direction, this will be the line of action of this force. Okay. So to find the direction of moment, you have to use your right hand plumb rule. Right hand plumb rule. You might be facing problem that what means right hand plumb rules. Simply you have to put your right hand of plumb of this face in the direction of line of action of force and just bend the fingers in the direction of X. Then the thumb will show you the direction of movement. It means that if we put our right hand in the right hand plumb in the direction of line of action of force and curve it to the axle, the thumb will pointing outward perpendicularly from this board. Or if you are writing on the paper, it will be perpendicularly outward from that paper. Okay. So the hinge will, the axle will rotate in anti-clockwise, opposite to the direction of a clock. That is called as anti-clockwise. And the direction of movement will be perpendicularly out from the board, outward from the board, outward. Okay, outward. That is anti-clockwise, the direction of rotation of the axle, and outward is the direction of movement. Okay, you may, for the convenience, you may take it as a positive. Okay, similarly, the next case, in the second case, I am showing you. Here the force is applied from up to down. Okay. So the line of action of this force will be in this direction. Simply you have to put this face on the line of action of force. Okay. And curve it to the direction of action. The thumb will point out inward, perpendicularly inward. Okay. Inward means if you are drawing this figure on the plain paper, means perpendicularly into the page. Okay, as I am drawing this figure on the board, it means perpendicularly inside the board, that is inward. Okay, it means the object axle is rotating in the direction of the clock. That's why we have taken the clockwise, and you may consider it as a negative. Okay. Now, I think that you are able to understand this direction, and it might be difficult. It is easy to handle, but please repeat it and observe it, because you have to face it at each and every numerical problems of your notebook. Okay, so come to the point. Now couple. Next point is couple. First of all, think what do you mean by couple? Meaning of couple is when two force on an object just apply in opposite direction. Two force on an object just apply in opposite direction, and both forces are equal in magnitude. Then we say that the force is a couple. Means two equal and parallel, two equal and opposite parallel forces not acting along the same line form a couple. Simply, there is a rod. Let us assume here there is a rod. Force F on this green line. Green line is a rod. Force F is from upward to downward, and same force of same magnitude applied from down to up. Means in this condition both forces are equal and in opposite direction. Okay, and not acting on the same line, not acting on the same line. So we can say that this combination of force is a couple. Okay, a couple is always needed to produce a rotation in any body. Means that if you are rotating something, definitely there is a need of couple forces. There is a need of couple forces. If you are rotating it, there is a need of couple forces. Definitely. Okay. There is a condition. Now we have to find the formula of moment of a couple. Okay. So there is a condition. I have hinged a rod AB of length D, hinged at O पे मैंने इसको hinge किया है, टिका दिया है ऐसे. Okay. And applied force F at A and same force at B. Okay. So we know to find the moment. So moment of a force F at end A will be F into OA. F into OA. Then where will be its direction? Simply I have told you to make the line of action. Keep your right hand this to that line of action and curl into the perpendicular distances means action. And you will find that it is in anti-clockwise, that is perpendicularly outward. Okay. Again, moment of a force F at end B. Moment of a force at F at end B. And here I will do the same thing. Draw the line of action of force. This will be the line of action of force. Put this to that line of action and curl to the axis of rotation. Okay, curl to the axis of rotation, and you will find it is perpendicularly outward or motion is in anti-clockwise. Again, I have put it here anti-clockwise, and I have asked you to always keep in mind that anti-clockwise, for the sake of convenience, you have to put it as a positive. So it is also in positive, it is also in positive. So simply, total moment of a couple will be F into OA plus F into OA. Here there is a 2F, so we will take a common from this and we will find that OA plus OA. Okay? OA plus OA, that is equal to F into OA plus OB, that is equal to D. That is equal to D. OA plus OB, that is equal to D. So there is a formula of couple. We find that moment of a couple is equal to either of force. Either of force means either we will take this force A or this force A, because it is in same in magnitude but opposite in direction. Only direction is opposite, magnitude is same. So either of this force you will take it, and into perpendicular distance between the two forces. The perpendicular distance between the two forces is D, and we have to take the perpendicular distance between the two forces. So our permanent formula of moment will be, moment of a couple will be either of force into perpendicular distance between the two forces. Okay, thank you.